Welcome to your first video on Unit 1, Lesson 1. So in your notes, I'd like you to make note of this, that this is the first unit and the first lesson in that unit. So Unit 1, Lesson 1. And I want you to write your DOK. Your DOK is I will be able to use a quadratic function to answer questions about a problem in context. So what does that mean? That means basically we're going to solve quadratic equations, in particular in word problems, and we're going to find important things about those quadratic equations, all right? So I'd like you to take a minute and pause the video and write this down. All right, I hope you paused it and you wrote it down, and let's kind of get busy now. Let's start. So I have two investigative problems, I should say. And what I'd like you to do is I'd like you to try and solve these using the completing the square method. All right, you may not remember it, and hopefully you do. If not, you can look it up real quick. So I want you to try these using the... All right, guys. I don't know what happened. I'm having some technical difficulties here. I don't know where we left off exactly, but we're going to try this again. All right, so I want you to solve these by using the completing the square method. I don't know. Hold on. All right, so I'd like you to try solving these by completing the square. I'm not sure if you remember how to do that. I'm going to give you a little hint over here on the side with a reminder of the square root method. You use this method quite often, probably, in Algebra 1 to solve some of these equations. So if I had something like x squared minus 10 and I wanted to solve for x, I would use the square root method because it's not factorable, right? You can't easily factor it to solve. So in order to do that, I need to move the 10 to the other side because when we're solving for x, we want to get x by itself. So to move that x to the other side, the 10 to the other side, I have to use the inverse operation. So since that's minus 10, I want to add 10 to both sides. All right? So now I have x squared equals 10. So I want to get the x by itself, right? I don't want x squared, I want x. And so I need to undo the square. And the inverse of a square is the square root. So I'm going to square root both sides. And so when I square root both sides, I get x equals plus or minus square root 10. Do you guys remember why it's plus or minus? It's plus or minus because I don't know if x was a positive number or a negative number. And once I square it, it becomes positive. Like a negative 1 squared is 1. Or a negative 2 squared is 4, right? So it becomes positive. So 4 could be 2 squared or negative 2 squared, and I don't know. So we need to we have to include that as a possible solution, which is why we have negative, plus or minus negative root 10. So we have the positive and the negative. I'd like you guys to try solving these. If you forgot the square root method, it's not the end of the world today, but I'd still like you to take a stab at it and try. And I want to see this in your notes. I want to see both these problems with you trying to solve them that way. If you can't solve them that way, I would really like you to take and solve them using any method that you can, all right? And get the correct answer, all right? Because we're going to come back and we're going to try them again using the completing the square after we derive the quadratic formula, okay? The quadratic formula is amazing because it solves it solves any quadratic equation, right? It solves all of them. It doesn't matter what your solution is, if it's a real one or a complex one. We'll talk about that, the different types of roots a little later on. But this will solve any quadratic equation, the quadratic formula. All right? What you see here, below here, is the general form of a quadratic. F of x equals ax squared plus bx plus c. And what we want to do is we want to solve this for x. And in order to do that, we have to complete the square. So when I solve for x, I need the equation equal to 0, right? Your equations are always set equal to 0 because we're finding the zeros, we're finding the roots, we're finding the solutions, we're finding the x-intercepts usually, right? If it's a real answer, we're finding the x-intercepts. So when we do that, hence I said x-intercepts. That means the y value is equal to 0, or f of x here is equal to 0. So I have 0 equals ax squared plus bx plus c. Since we're solving for x, we want all the x's on one side and all the things without x on the other side. So I need to move the c to the other side, and since that's plus c, I'm going to subtract c on both sides, and that's by the inverse operation. And remember, what you do to one side of the equation, you always do to the other, no matter what. So I have a negative c equals ax squared plus bx. All right? One of the key things in completing the square is having 1 as a leading coefficient. You can't complete the square if 1 isn't the leading coefficient, and we can talk a little bit about that later. But right now, you need to know that we need to get rid of the a. And how do we get rid of the a? Well, I hope you said to yourself, well, Mr. Moore, it's because we divide the a out. We divide a on both sides. So then we have 1 as our leading coefficient, because the leading coefficient, remember, is the one in the front with the highest degree term, and the highest degree here is x squared. So we divide both sides by a, and we now have a negative c over a equals x squared plus b over a x. So far so good. This has not been too bad for completing the square, but now comes the tricky part. Alright, I want to find something that I can add to both sides of the equation, in particular the right side. I want to add something to the right side of the equation that's going to make that a perfect square. Alright, so that it factors into x plus something squared. Alright, and there's a method for coming up with that. Okay, that's part of the completing the square method. What you do is you take the middle term, or the term with the x, which is right here, the b over a, and you multiply that by 1/2. So I have 1/2 times b over a, and then you square it. And that's what you add to both sides. So I end up with b over 2a squared, which is b squared over 4a squared. And that's what I'm going to add to both sides. So I have b squared over 4a squared. I'm going to add b squared over 4a squared. So let's write that out in our next line. What do we have now? Now we have b squared over 4a squared minus c over a equals, well, how is this going to factor? You're probably thinking to yourself, that's going to factor into x plus b over 2a squared. All right, if you don't see it, look at it, think about it for a little while, and hopefully you'll see it. But I want you to notice that what we added here, that b over 2a, right, is the same thing as taking that middle term and multiplying it by 1/2 before we actually squared it. So that's what it's always going to factor into. All right? So if you remember that, that'll be helpful. I have these two fractions on the left side, and I want to combine them into one fraction so I can take the square root a little easier, right? So I need to find the common denominator. What's the common denominator going to be? Well, I notice that I have a 4a squared and an a. So that means my term that's a negative c over a is going to need a 4 in the denominator and one more a. So I'm going to multiply by, sorry about that, so I'm going to multiply by 4a over 4a. So I end up with b squared minus 4ac all over 4a squared equals x plus b over 2a squared. Now remember, we're solving for x. Remember from the square root method? So now I want to take the square root of both sides. So I'm going to square root that. And remember, it's when we take the square root, it's always plus or minus. Okay? By the properties of the square roots, we can actually break that fraction up into the square root of b squared minus 4ac all over the square root of 4a squared. And remember, that's plus or minus equals x plus b over 2a. We're solving for x, right? So that means we got to move that b over 2a to the other side. So I'm going to subtract b over 2a. Okay? And I'm going to simplify that radical. So I end up with a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a equals x. So that means that x is going to equal a negative b plus or minus b squared minus 4ac all over 2a. And that is the quadratic formula. And that is what is going to solve all of our quadratic equations. With or without a calculator, this will always find the exact answer, no matter what. No calculator needed. This will find the exact answer, which is why we love it, and which is why it's so, so great. Now, hopefully you picked up enough out of this to see how to complete the square. And I'd like you to go back to these problems here, and I'd like you to try and solving them by completing the square, okay? So I'd like you to take a minute and pause the video. Make sure you have those notes for the quadratic formula down there and deriving it. And I want to make sure that you can, I'd like to see you now write these problems down again, and I want you to complete the square on them, all right? You got it? So take a stab at it, pause the video. All right, good. Now you should have the solutions already because you solved it using a method you already know. But in case you don't know, I'd like you to take a minute again and pause the video and solve them by using the quadratic formula. And I'm going to help you really quick by helping you identify A, B, and C. Hopefully you can recognize them yourself. In the first one, A is, remember, A is the leading coefficient, goes with the x squared. So I don't see anything there. So if I don't see anything there, I assume that it's going to be 1, because 1 times any number is any number, right? So A is going to equal 1, and then I have B. B is with the x, so that means that B is going to equal 2. And then I have, let's see, different color. I have C, and I have a minus 3 there. So that means that C is going to equal a negative 3. And I'm going to plug those numbers into the quadratic formula, and that is going to give me my solution. So I can check my answers as well by using the quadratic formula. And I'd like you to take a minute now and solve these two problems using the quadratic formula, all right? So take a minute and do that real quick. Pause the video and do it. All right. The next thing we're going to want to do is we're going to use these same equations again. I mean, why not? And hopefully we're going to remember how to find the vertex and the y-intercept, right? Hopefully you remember how to do that. So the vertex is the maximum or minimum value. It depends on which way your parabola is opening. If it's opening up or opening down, right? That's going to give us our max or min. It's going to tell us if we have a max or min. And the a value is what's going to tell us whether it's opening up or down. All right? And it's going to tell us if it's a max or a minimum. So if a is greater than 0, that means a is positive. Then I have what? I have a parabola that opens up because it's happy. It's positive. It's happy, happy, happy. Right? So it opens up, and we're going to have a minimum value at the bottom. If a is less than 0, that means it's negative, and it's opening down, and it's sad. It's negative. It's not very happy. So it will have a maximum value. It's going to have a top. All right? So that's how we know whether it's a maximum or a minimum, by the a value. Hopefully you remember how to find the vertex. If not, I have a little side video where I kind of give you the formulas for that. But just a quick reminder, if you didn't get over there to check those out, the vertex is, remember, the vertex is hk, right, for a parabola, and h, when it's in the general form, is a negative b over 2a, and k is equal to f of h, which means I plug in whatever I get from my x value, and then that'll give me my y value. All right, there is a formula for that, but it's kind of lame to remember a formula when you can just plug it back in and solve. I don't believe in formulas if you don't need them, okay? Especially if you understand what you're doing. So that'll find my vertex. The y-intercept, remember that's where x equals 0, right? So the y-intercept is going to equal f of 0, which is some number. That just means you plug in 0, right? So I'd like you guys to take a stab at this and find those things really quick. All right, pause the video and do that. And then I'd like you to solve this problem. And I want you to sketch the graph, all right? And I want you to label, it says label the axis and key characteristics. Notice here that this one is opening down. That's kind of important, right? The key characteristics that they want you to label are these things. Are you ready? That would be the vertex, the y-intercept, x-intercepts, if there's more than one that makes sense in this, and the max or min, which is the vertex, y-intercepts, x-intercepts. Let's see, are we missing anything, guys? Those are the major points. And if these graphs intersect, right, points of intersection, those are kind of important. Points of intersection. All right, I know it doesn't quite fit there. All right, so I'd like you to take a minute, and I'd like you to solve this problem and graph it and answer these questions, okay? You have all the skills you need now to do that. So I'd like you to, this is it for the video, so you may want to back it up and figure this out, all right? You have all the tools you need now to solve it, to find the vertex, the max, the min, the exact value, right? You can find the exact value for the x-intercepts by using the quadratic formula. Okay? So it's a little bit of work, but you should be able to do it, guys. I hope you have a good weekend, and I'll see you Monday.